Okay. Sum and difference formulas for tangent. What page are we on? We're on page 14. This is the sum and difference formulas for tangent. So we are going to plug in similarly to what we did with our sines and cosines. But if you notice, our formulas are a little bit different here, right? For tangent, if we are subtracting here, notice if it's subtraction inside that parentheses, then it's subtraction on the top and it's addition on the bottom. Notice these two things are getting multiplied together. And then similarly here, if it's plus in between, then it's plus on top and it's minus on the bottom. Okay? So that's key, once again, is just determining which formula we are going to use. Obviously, just by looking at it, you can tell that the formula's a lot more involved than the sine and cosine formulas. And I'm going to kind of show you kind of some hints or tricks about dealing with the formula here in just a sec, okay? All right, we just did a problem with the 7 pi over 12. So let's use those same angle measures again. We could use different ones if we wanted to. Any angles that add or subtract to give us 7 pi over 12 that are on our unit circle. Okay, but I'm going to use the tan of pi over 3 plus pi over 4. That's what Talia had just said for the other problem that we practiced. So let's use those. So we're doing tangent of A plus B there, right? Or U plus U and V, however you want to think about that. They've got U's and V's here. This is telling us then that we are going to do the tangent of pi over 3 plus the tangent of pi over 4 all over 1 minus the tangent of pi over 3 times the tangent of pi over 4. So be careful, that is multiplication there. Okay. All right. Okay, so recall that when we are looking for tangent values on our unit circle, it's y over x, because it's sine over cosine. If it's some of those funky fractions, remember we're doing the numerator of the y over the numerator of the x. So tangent of pi over 3, find pi over 3, and what is the tangent value for that? Vivian? Okay, yep, we get root 3 plus the tangent of pi over 4. Elena, what do we get for that? 1, yep. And then all over 1 minus, and then we're just multiplying those two values together. So if we multiply the square root of 3 times the square root of 1, we just get the square root of 3. Okay. And the issue is, obviously, you guys have picked up on this and noticed, I'm sure, we've got radical in the denominator. So we've got to multiply by the conjugate. And then we can clean this up. So that means we've got to multiply by 1 plus the square root of 3 on both top and bottom. I'm actually going to write out the denominator first, just because that's the easier of the two. Because remember, if we're multiplying by conjugate, you just have to multiply first and last. So for first, we get 1. With the last, we get minus 3. Okay? In the numerator, though, if we're multiplying first, it's square root of 3. Outside, that's the square root of 9, which is just equal to 3. Right? And then inside, if we're multiplying the inside, that's 1 times 1, so we get 1. And then for the last term, we're multiplying 1 times the square root of 3, we get the square root of 3. Okay, take a look at that. Make sure you follow how I did FOIL that. I went in that order. First, outside, inside, last. But now we need to look at what like terms we have. So we have these two terms that are common. and these two like terms that we have to combine together. So the 3 plus 1 gives us 4, and then the root 3 plus another root 3 gives us 2 root 3s, and that's all over negative 2. The thing to notice, we're back to Mickey Mouse ears, guys. Right? We have Mickey Mouse ears here. So we've got to divide. So I want to divide out the negative besides the 2, right? So 4 divided by negative 2 gives me a negative 2, and 2 divided by negative 2 gives me a negative 1. If you want to put the 1, you can, but you don't have to. So here's our final answer, is this negative 2 minus root 3. And guys, all of your answers for a tangent problem of this type, where it's asking you to add or subtract to get that value, all of your answers are going to be this format. So just as with our sines and cosines, it was a square root, it's a square root of 2, a square root of 6, all over 4. With this one and the tangent, at the end, you should have a 2 and you should have a square root of 3. The signs are going to be different depending, but okay. All right. Alex, Tina, you good? Okay. I can talk through something if you need me to here. I went kind of quick. I was trying to slow myself down here, but if I need to go through and explain something, I can. All right. Questions in terms of the process, or kind of answer you're going to see, that type of thing? Okay, I need you to think about this for a second. I'm going to jump down here for just a quick sec. If you notice, I'm giving you this hint and this reminder. I need you to think about what our 30-degree reference angles are, because it's not just 30 degrees, right? It's 30 degrees, it's 150, it's 210, it's 330. All of those are our 30-degree reference angles. They correspond to the radian measures of pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. If you're doing a tangent problem, if you can, you want to try to avoid using the 30 degrees or the pi over 6. And I need you to think about why. I want to show you an example of how you have to work through that process, because it's a little more involved. And I want you to see what you want to try to avoid, right? But I want you to have an example so that if you do use a 30-degree reference angle, in some instances you can't avoid it. You have to use it. So you do need to know how to do with it, right? Okay, but just that reminder, and it's not just 30 degrees, but all of your 30-degree reference angles also. So 150, 210, 330, right? And your pi over 6s. Okay, so we want to do this tangent of 75 degrees. I want to show you, I want to purposefully choose to use 45 plus 30 degrees so that you can see how we have to do with that 30-degree reference angle with the tangent. So we have angles that are being added to get to that. So to plug into the formula, look at the right-hand side. We're going to do tan of 45 plus tan of 30 degrees all over 1 minus the tangent of 45 times the tangent of 30 degrees. Okay, here's where it gets a little bit messier, and you'll see how we have to deal with this. All right, tangent of 45, that's a nice pretty 1, right? The issue is the tangent of 30 degrees, we do numerator of the y over numerator of the x, right? And so that gives us the square root of 3 over 3 once we've rationalized that. So that's our numerator. And then we have 1 minus, and we have to multiply 1 times the square root of 3 over 3. So we still get this other square root of 3 over 3. So this is why you want to try to avoid the 30-degree reference angles. If you look, if you notice, we've got complex fractions there, right? Not very pretty. Okay, here's how we're going to deal with that, though. First thing, we need common denominator. So I'm going to kind of write over this. It's not ideal, but I think you guys can see. Instead of thinking of that as 1, I want to rewrite that as a 3 over 3. Right? Okay, so now think about what we have here. We have 3 plus the square root of 3 all over 3. And then all over 3 minus the square root of 3 all over 3. You see that? I've just rewritten numerator and denominator with my common denominator. Okay, now if I do keep it, change it, flip it, if I flip this up, what's going to happen with the 3's? Those 3's divide out, don't they? Right? If I do my keep it, change it, flip it, then I have 3 over 3 minus root 3. And the 3's divide out, and I'm just left with, in the top, in the numerator, I'm left with this. In the denominator, I am left with that. So you can kind of skip this step if you can see it right away. Once you get to this particular place in the problem, if you notice and realize that the 3's just are going to divide out, then you can go straight to these numerators and you can go straight to this if you would like. I'm fine with you doing that, if you see that. Okay? We aren't done though, because we've still got radical in the denominator, right? So what are we going to multiply by on top and bottom? There you go. Yes, Lucy. 3 plus root 3 on top and bottom. And then we've got a FOIL. So for me, I like to get the denominator dealt with first. It's just faster and easier. So first in the denominator is going to be 9 minus the square root of 9, which is 3. So that's denominator. That's taken care of. Okay, numerator, though, takes a little bit more time. Are we good up to this point, guys, before we start foiling? Okay, all right, so first is 9. Outside gives us a plus 3 root 3. Inside gives us another plus 3 root 3. We'll combine that in a second. And then the last, we're adding root 3 times root 3, so root 9, which when we square root that, we get a 3. Good morning. Yeah, I just said it right there. Thanks. Okay, are we okay with that foiling? Okay, so once again, we need to look at what's in common here that we need to combine together. So I'm going to try to color code that for you. So for our denominator, we've got 6. In the numerator, the 9 plus 3 gives us 12. And then the 3 root 3 plus another 3 root 3 gives us a 6 root 3. I'm trying to color code that for you to take a look at that and see. And then, this is just so pretty because we get Mickey Mouse ears again. And 6 goes into each of those things. So 6 goes into 12. So we get 2 plus 1 times root 3. So once again, our answer was still similar format there, but this few more steps involved, right? In terms of dealing with the extra fractions. So that's why I gave you this note about, if possible, avoid those 30-degree reference angles, those pi/6s and stuff, right? Okay, on to the next page, a little bit more that we're gonna look at there, and then I'll explain what your classwork and homework is, okay? Questions or comments, thoughts on these? Hopefully you wrote those out carefully so that you have that to kind of go back and look and refer to in you're having trouble. All right, we are working backwards in this case, right? If you notice, we are given what looks like the right-hand side of the equation, right? So the thing to notice or pick up on is this, whoops, let's highlight that in a different color. That sign is going to help us decide how we're going to write this. We know it's going to be a tangent. We know it's going to be two angle measures that we're either adding or subtracting. This minus sign here tells us it's going to be subtraction. And so then we're just plugging in those angle measures. So 78 minus 18. So we get the tangent of 60 degrees. And if we go to the tangent of 60 degrees, we can find that answer. Tangent of 60 degrees we know is just equal to the square root of 3. Okay. All right, this last example, I'm going to ask you, if I give you something like this, I'm going to actually be asking you to kind of work in both directions. Like I've given you what you're going to plug in. So we're going to go to unit circle and we're going to come up with those values. But before we do that, you might also be asked to look at your formulas. So take a peek at your formulas. Notice that sines and cosines are mixed together. So does that mean we're talking about a sine or a cosine problem? Go back and look at your sine and cosine formulas. Page 13 or the back of your supplementary packet. If the sines and cosines are mixed together on the right-hand side, does that mean we're talking about a sine or a cosine formula? Sine, good, okay. So we know we're dealing with a sine of two angle measures. It's plus here. So given what we know about the formulas, that means it's going to be plus here. So we are going to add pi/3 and pi/4, the angle measures. And if we find common denominator and actually add those together, then we know we've got the sine of 7pi/12. But now the other part of this, so that could be part of what the direction is that I asked you to go with it, but we can also go to our unit circle and actually find these values, right? So sine of pi/3, what does that equal to, guys? Yep, root 3/2 times cosine of pi/4 gives us the root 2/2 plus, here's where the 1/2 is, right? Cosine of pi/3 gives us the 1/2 times the square root of 2/2, so we get square root of 6 plus square root of 2 all over 4. So you're kind of going two different directions if you're given something like this, right? You might have to figure out which equation we're dealing with, and then, okay, by the way, what's the answer also? Okay. All right, pages 16 and 17, there were some problems you have not done yet because they were tangent. Page 24 is a little bit longer, and it is a mix of sine, cosine, and tangent, okay? Desks were moved this way because my earlier class had a test. You can totally move the desks and work with somebody. I want you to do that so that you can help each other with this, okay? And I'm gonna float around also as usual just to kind of peek over shoulders and see how you're doing. Okay, so 16 and 17, what you haven't finished from those pages, and then page 24.